See, don't ever let anybody tell you you don't have power, all right? Okay, this is a special kind of tipping problem. And this is a very crummy drawing, but it'll have to do. What we have here is a motorcycle. I was trying to find a YouTube video that fit this, but I thought that just, anyway, I couldn't get that done, but. And this is Y sub B. Okay, situation is, here we go. We got a motorcycle and a rider represented by this artfully drawn diagram here. It's got and the situation is right here is the center of mass, G, of the motorcycle rider unit. Okay, we're assuming the rider and the motorcycle are of okay. Here's the question. Okay, at what acceleration of point A here, at what level of acceleration, at what level of, will this thing tip over backwards? All right, begin to tip over backwards. All right? Anybody here have a motorcycle? Good. As a parent, oh, I'm sorry, there's one. There's one. You have a motorcycle? I used to have a motorcycle. Let me just say, doing a wheelie on a motorcycle is very exciting. Right? Riding a motorcycle is exciting, but it does not do anything to extend your life expectancy. Let me simply say, let me go on the record as saying you have no business on a motorcycle. So enough of that. I'm not your mother. I'm just saying you don't have any business on a motorcycle. I've been there. Okay. And this is what I want to say, begin to tip, okay, or the so-called onset of tipping. Now note, and this is kind of key, at the onset of tipping. That's basically when it starts to go, but it hadn't gone yet. Okay, these are three kind of common sense observations that you might make, and if you don't, or you should make, but if you don't, you're going to be hard pressed to solve the problem. First is that because we're talking about the onset, the incipient tipping, it hasn't begun yet, the angular velocity of the rider and motorcycle combination is 0. Okay, the angular acceleration, again, this is omega, and that is alpha. Omega is 0, alpha is just barely 0, just slightly larger than 0. In fact, that's what we're looking for, is the point at which that begins. And then the last point is, again, at the onset of tipping, the normal force under the front wheel is, for all intents and purposes, 0. So what we have is, this is our free body diagram. I want to draw our free body diagram here. This is point A. I'm going to choose our little bitty local coordinate system, OXY. Okay, here is the normal force. This is our friction force. This is and this is Y sub B, and this is X sub B. Okay, and what else do I need here? Oh yeah, point A is, if bear with me, I'm going to take that out. I'm going to say is accelerating in that direction. It is in fact a vector, but we know what it is, and this is our fixed coordinate system is over here someplace. All right, so here we go, and I'm going to do this relatively quickly. So, nothing is unusual yet. The acceleration of point B, this is simply our formula of old. Excuse me, I'm mixing my metaphors here. Skipping a line here. And that's not omega, that's alpha. Okay. Filling in the blanks. Little a sub a times I minus alpha y sub b. Trying not to leave out steps. We left out something here. There we go. All right, now let me just check a moment to make sure this is correct. It is, okay, so that is the acceleration of point B, the center of mass, which is in this case the center of mass of the motorcycle and rider pair. And now, okay. Everybody with me so far? This is, how about Kathy in the back? She's still up there? Can you read this?
Yes.
You sure?
Yes, I can.
Yeah, okay, very good. This is, for those of you, I've just seen some of you squinting here, this reads F equals M A sub A minus alpha Y sub B. This reads N minus MG. This is the summation, obviously, in the plus X direction. This is in the plus Y direction. Summation of forces, normal force minus the mg is mx. That doesn't look right, does it? Oh yeah, no, that's, yeah, no, that's right. Okay, and then F sub y sub a, no, this is okay.
So the second equation to the right of the equal sign reads what? The second equation.
M times alpha times x sub b. All righty?
From here, the alpha looks like a cross product.
Ah, that's the problem. All righty. Well, let's see. I don't know what to tell you here. A little better. Okay. Very good. Let me just say, oh, good. We'll get this done here. So let me number these. Okay. What I've got here is 1 and 2 and 3. And what we're going to do is we're going to take 2 and 3 and substitute them into 4, essentially eliminating the F and the N. And here's what we get. That's an alpha. And the other one, you get the second one, you get this, or excuse me, this, just keep on doing it. And then oh, this won't go up. All right, now I'll give you a minute to copy that down, and we still have time for the last segment. I promised the fellows in the booth I would stop walking around, like, because they have to follow me. Okay. So let's just review the bidding. Everybody get the idea here? Okay, that's as good as it's going to get. All right, here is the situation. As we said before, we have two forces, F and N. We apply N being the normal force at the rear wheel, F being the frictional force associated therewith. We don't know either of them. We don't know whether positive or negative or what. No matter, we blithely use them in Newton's laws, summing forces in the x direction, summing forces in the y direction. We know we have previously obtained the acceleration of point B from our trusty formulas of last week. We get the moment expression here. Here we substitute these two guys into here to eliminate F and N, and some algebra later, we are left with this. And here's the key reasoning. If you look at this, look what this says. This says all of these things over here equal something like a moment of inertia, times alpha. Okay, we are looking for the point at which alpha becomes greater than 0, because that's the beginning of the tip, shall we say. So it is when this term over here is larger than 0, giving us this expression right here. Everybody get it? So, if you will, the taller it is, yeah. You got a question, or are you doing the right-hand rule? No question, okay. Yeah, well, anyway, suffice it to say, I think you can just tell by looking at this that you can and should always check with your intuition. What would you expect to happen if you were a great big tall person riding a motorcycle? Or, God forbid, you had somebody having your buddy stand on the rear seat so as to raise the center of gravity. Is that going to make your stability improve or deteriorate? What do you think, Robin? If the center of gravity were to get larger for any reason, which would mean y sub b would be large, what does this equation say?
That you can have more information.
What it would say, the smaller the acceleration you can get away with before it's going to fall over. Okay? Conversely, the lower the center of gravity, the more acceleration you can do. That's why race cars are flat. All right? Indy cars are 2 feet high. Okay, question, comment? Wonderful. Nico, satisfied? Okay.